Hi, this is the Buddha tape feeder that I've generated for the Arcus 3D P1 pick and place 3D printable project. So I didn't really like the fact that the existing 3D printable pick and place tape feeders required motors or weights or some other weirdness for retracting the cover tape. So I developed one with ratchets that does the same thing using the bump feed or servo mount. I'll show you that later. So here we go. A little bit of the cover tape sticking over there still. I need to pull it back a little further. So, here's how I did it. So, this is a little snap-on thingy. This is the cover tape tension. So you reduce this, and then you can just pull on it. Oops. I didn't glue those in. So it's based on a system of ratchets, some skateboard bearings, and I didn't glue anything together. An O-ring right there for the tape tension, which slides against the top of this, which is spun by these ratchets. So, like that. The motion of this rides on the outer surface of this bearing. And the same thing over here. Got a ratchet on the inside of that. Teeth on the edge to, teeth on the edge to grab the tape, and that's printed against the bed, so it's a nice, perfect surface there. And then what allows me to do this is, well, one of the design features is, I can't see, there, okay, is that I designed it to hold the tape, too much noise, hold the tape between here and here, and then there's a little bit of an angle right there and there, and so this is allowed to flex. I made it thin enough so that as the tape rides in, this gets spread out just a tiny bit, and therefore the tape is held up against my cover slot. So the top of the tape is always at the same height. Okay? And then wrapping it up, there's another stray component somewhere. Another ratchet to prevent the reverse of the drive wheel, and then this to actually drive it. Which is a pen spring, another little 3D printed bit, and a piece of piano wire. There's two pieces of piano wire here that serve as posts because we're going to get a lot of wear, because that's where my cover tape retainer snaps on. So you can print these in any width you want. So 8 is right now. You could go up to 24, and I don't foresee any problems because of how the the bearing is doing the is supporting the load, keeping it centered. And then there's it actually slides very gently against the surface here on these high points to keep it, stable in the this dimension. There's also a spot for a servo here. This isn't the right one, but you can put a servo here for a single wide, or you can put a servo here if you want to use a single servo for two. It's just a connecting rod between this slot and here, and the slot allows this to move back and forth still while the servo is connected, and allow the neighboring unit to advance without affecting this unit. So a 90-degree turn of this will give you one advancement. A 90-degree in the other direction will give you an advancement of the other one of these units. So that is that. I hope you like it. Sources up on Hackaday. And like and subscribe, please. Thank you.